Hello guys, welcome back to another problem solution video. Today we review another question here, and as always, let's first start by reading the question. So, let a equal to 0, let o be equal to 0, and let c be equal to c0, and b be equal to cb, okay? Where a, b, c are positive integers. Now let's let point p be at po, and this be the point on the line segment OC that minimizes the distance between the distance of AP plus PB over all choices of P. So let's let X equal to AP plus PB. Now we need to find out, show that the minimum distance of X is going to be equal to C squared plus A plus B squared in brackets. So here, I've already drawn the graph, okay? So obviously we have A, P, O, B, and C, right? And obviously we have the triangle APB here, right? And then we obviously have A, P, all of the lengths up. So in order to solve for A, we know that X, right? X is going to be equal to AP plus PB, so AP plus PB. And what we can do here actually is just reflect B. So I've already drawn this beforehand to save some time, but we can reflect B off of the x-axis into this point here, which is a B apostrophe, right? And so this point, so P to B apostrophe is going to have the same distance as P to B apostrophe. And so in other words, this means that this length here, so X, so in other words, A to B apostrophe, that's going to be the length of X. But obviously, what is this length? Well, it's actually pretty easy to solve. We know that this height here is going to be B, right? From the x-axis to B, we know this length is going to be B. And so when we reflect it off to B apostrophe, this length is also going to be equal to B. And so in other words, what x is equal to is, we can look at Pythagorean theorem here. We have A, B, and let's say we have another point here, right? This triangle, which is going to be perpendicular here. We can say this is a right angle triangle where we have height A plus B, and then our length would just be C. And so x would be equal to AB apostrophe, which would be equal to square root C squared plus A plus B squared, which is pretty simple. So now let's solve for part B of the question. So let's say C is equal to 2. Now we need to find all pairs of AB for which all the variables A, B, P, and X are positive integers. So let's say C is equal to 2. So I'll write this as part A, so now we know that this is part A. Now we're going to move on to part B. So move down a little bit. Part B. So C is going to be equal to 12, as given for the question. And we now know that X squared is going to be equal to C squared plus A plus B squared, as proven in part A. Now, because we know that C is equal to 12, we just plug this in right away and receive 144 plus A plus B squared. Right? So let's move A plus B squared to this side with X squared, and let's keep 144 here. Now, this is going to be equal to, write a new line, X squared minus A plus B squared, right? Obviously, this is in the form of X squared minus Y squared, so this is going to be equal to, in brackets, X minus A plus B in brackets times X plus A plus B in brackets multiplied by, equal to 144. Now, something you need to realize here is that these two terms, so X minus A plus B in brackets and X plus A plus B in brackets, we can see here that both of these terms have to have the same parity, right? This is because obviously we have the same variable, so if I were to replace A plus B with a different variable, let's say like Y, obviously X minus Y and X plus Y would have to have the same parity, or they would both have to be equal to even or odd. Now here, we see that they both multiply together to be something that is an even number. And since we know that these two both have to be the same parity, we know that both of these have to be even, right? So now we know that this, 144, this can be equal to 2 times 72, 4 times 36, 6 times 24, 8 times 18, or 12 times 12, right? And so this means I can write out a little table here with X and AB. But not really a table, I'll write it in brackets. We can see here the relationship between x and a plus b here, we see here that we can get these pairs. So if x is equal to 37 and a plus b is going to be equal to 35, that's a pair. If x is equal to 20 and a plus b is equal to 10, so not 10, 16. And obviously, we have a bunch of more. So, for example, we have 13 and 50, 13 and 5, 12, actually I'll write this on a new line. 12 and 0, and 15 and 9. Obviously, 12 and 0 won't work here because we know that a plus b can't be equal to 0 because they're both positive integers, so we can immediately cross this out. Now, let's look at the rest of this, and now we need to solve for what a plus b is and what a and b are respectively, and why, and we also need p to be a positive integer as well. So going back to our graph here, as you can see here, by symmetry triangles here, we have AOP and A, I'll actually just write a point here, let's just write Q, AQB. We know that these triangles are going to be similar to each other, and we can easily see here, since the bottom part is 12, because this bottom part is C, we can see that P divided by 12 is going to be equal to A divided by A plus B. So in other words, I'll write it down here. P divided by 12 is going to be equal to A divided by A plus B. And so by cross multiplying here, we can then receive that P is going to be equal to A divided by A plus B times 12. Now, assuming that, obviously we need to know that P is going to be a positive integer. So let's just assume that P is a positive integer. This means that, well, A divided by A plus B times 12 also has to be a integer, or positive integer. Now, if you plug in something like A plus B is equal to 35, like in this pair here, we can see here that this is going to be equal to A divided by 35 times 12. And there's a big problem here. We know that A also has to be a positive integer, but no positive integer can make it so that A divided by 35 times 12 is going to be an only integer, right? Because they don't have any common factors. And so we see here that this pair, 37 and 35, where x is equal to 37 and A plus B is equal to 35, won't work. Same thing with if x is equal to 13 and A plus B is equal to 5, because, well, let's just say in an alternate reality, this is A divided by 5, right? Let's say I said A divided by 5. So we plugged in this pair here. Same problem. No value of A is ever going to make this into an integer, right? Unless, yeah. Positive integer, by the way. So this means that the only possible pairs are if A plus B is equal to 16, or if A plus B is 9. So if A plus B is equal to 9, or if A plus B is equal to 16. But here, you just need to plug in these numbers here. So, for example, A divided by 9, and then we can solve for all the pairs. So here we have, for both of these, we can have 3, 6, and 6, 3 in the form AB in brackets. And then for the bottom one, pretty similarly, we have 4 and 12, 8 and 8, and finally 12 and 4, which is the opposite. So this means that if we want all of these variables to be positive integers, and we know that C is equal to 12, all the possible pairs for A and B here are going to be 3 and 6, 6 and 3, 4 and 12, 8 and 8, and 12 and 4. Thank you guys for listening. If you've any other way to solve this problem, please let me know down below in the comments, and thank you guys for listening. Bye!